This presentation is on MuleSoft's Anypoint Runtime Fabric, and this presentation was completed in the Denver MuleSoft meetup group. Feel free to reach out to the organizers for any additional questions, which would be Aaron Lieberman and Linda Gunn from Big Compass. So we are here to talk about Anypoint Runtime Fabric. And this is meant to be a mid to high level overview of Runtime Fabric. I get a lot of questions on what is Runtime Fabric. I see a lot of curiosity out there in the industry on Runtime Fabric because people know that it's combining some great facets from on-premise deployments with some cloud features and benefits. And so we're going to go over what is Runtime Fabric and answer that question. And we're going to look at some of its key features and benefits, as well as an installation that I did for the demo that we're going to look at the end of the presentation. And we'll look at how Runtime Fabric can power you to run Mule 3 and Mule 4 on the same set of resources, and how it performs high availability and gives you high availability that is so desperately needed for many organizations today. And so this is not really meant to be a low-level presentation. It's meant to kind of take a step back, assess Runtime Fabric, answer what it is, and for you to be able to tell if this is right for your organization. So Runtime Fabric, let's answer the question, what is it? Runtime Fabric is a container service that allows for automated deployments and management in the cloud. It runs on your infrastructure, but it connects your on-prem deployment to the cloud. So what I like to say is Runtime Fabric really combines some great facets from on-prem and the cloud and gives them to you in one offering. And so what that allows you to do is get some of the great features and speed of the cloud with your on-premise deployment. So let's look at some of the Runtime Fabric features. The number one feature that people are looking for out of Runtime Fabric is application isolation. And so we know with on-prem deployments today that one application can affect another. And we obviously don't want that. With Runtime Fabric, under the hood, it's powered by Docker and Kubernetes. And so it gives you complete application isolation even when multiple applications are running on the same server. And so something can go wrong with one application running on your infrastructure, but it will never affect other applications running on that same server. And then you get the capability to run multiple versions of the Mule runtime on the same set of resources. And we know that's not possible today with an on-prem deployment. But with Runtime Fabric, it is, and it's powered by that application isolation and Docker and Kubernetes under the hood, where each application running on your set of resources is in its own container and completely isolated on its own runtime. And so that allows you now to run Mule 3 and Mule 4 on the same set of resources. And then you can easily scale applications. So again, the use of Kubernetes under the hood allows you to scale your applications up, or you can scale applications out, which is called replicas with Runtime Fabric, across your servers. And you can do that at the click of a button. It gives you automated application failover. So Runtime Fabric is smart enough to keep tabs on the number of replicas of an application you want running at any one time. And it will deploy another replica of your app in the event of an application failover. And so if anything goes wrong on one of your applications, Runtime Fabric will spin up another replica of that application to keep you highly available and to keep you at the number of desired replicas that you want. And then you get out-of-the-box management with Runtime Manager using Runtime Manager and Ops Center. And so this is really unprecedented for an on-prem deployment, the management you get here. It's really management of the cloud brought to you in an on-prem deployment. So from all those features, I see three main benefits. Number one is high availability. And with high availability, you get that automated failover of applications. You get the application isolation. and you get rolling deployments with zero downtime. And so if deployments are a pain for you, you might consider Runtime Fabric, and we'll look at that in use cases here in a little bit. You also get speed and agility. And by speed and agility, what I mean there is really you get the speed of the cloud. You get centralized management where you can easily deploy and secure and scale and monitor your applications. And you can connect your applications to the cloud to be able to enable non-technical users to be very effective in managing your applications. And all of this can be deployed on AWS or Azure or your own data centers. So it's very flexible in how you actually deploy Runtime Fabric. So as with anything, it's very important to look at use cases. And so you want to take a step back with Runtime Fabric and make sure that it fits your organization. And that's why we're going to talk about use cases for Runtime Fabric. The number one use case that I see is when hosting location is important. This Runtime Fabric could be a great option for you. Runtime Fabric would allow you to host your applications where your data resides to power your internal processes or applications or systems, but still get some of those great features and benefits of deployment that's very similar to the cloud. When compliance and security might mandate that you can't deploy to the cloud, if your organization just simply won't allow you to deploy to the cloud, Runtime Fabric might be a great option for you because you can still deploy to your own infrastructure that your organization would allow, but then be able to manage your deployment from the cloud. And really in general, any on-premise deployment would probably be a candidate for Runtime Fabric. What you get out of Runtime Fabric is those great features and benefits that really enable application management. And application management is really a key use case here. It allows you to manage your applications very similarly to how you would in the cloud. You can scale and monitor and deploy your applications really with the click of a button. Another really great use case for Runtime Fabric is to speed up and enable deployments in your organization. You can really deploy at the speed of the cloud thanks to Docker and Kubernetes under the hood. And you can speed up deployments for your organization with rolling deployments with zero downtime that really allow you to sleep well at night. So if deployments affect your business continuity today, Runtime Fabric might be a great option for you. And last but not least, application support is a great use case. What Runtime Fabric really does, again, is bring some of those great cloud benefits in terms of enabling non-technical users and ease of use and ease of management to an on-premise deployment. So if you want to enable your non-technical staff to be able to easily support your applications that are deployed on-premise, Runtime Fabric is a great option for you. So when you compare an on-premise deployment to a Cloud Hub deployment right next to a Runtime Fabric deployment, I think it becomes very obvious how a Runtime Fabric deployment is different and the same as a cloud and on-premise deployment. So with an on-premise deployment, we know that it's hosted on your own infrastructure and it's controlled from MuleSoft's control plane. And the struggle with an on-premise deployment today is really the lack of isolation. So if an application running on your server goes haywire, we know that it can affect other applications running on that same server. You also have a little bit of rigidity in that you can only deploy one version of MuleSoft to your server. And so you can't deploy Mule 3 and Mule 4 to the same set of resources with an on-prem deployment. You might also struggle with deployments on-premise today. And with Cloud Hub, just to be clear, this is still the recommended option from MuleSoft. So if you can deploy to Cloud Hub, that's still a great option, still the best option. You get enablement in MuleSoft's cloud. You get the ease of management from the cloud, and you get rolling deployments and isolation and zero downtime. And you get to deploy multiple versions of MuleSoft really at the click of a button, and you get high availability with load balancing with the Cloud Hub deployment. And so now when I explain a Runtime Fabric deployment, you're going to see that it sounds very similar to a Cloud Hub deployment, but it runs on your own infrastructure. But everything else is basically the same as a Cloud Hub deployment. So you get the cloud-like application management and the ease of management when you deploy to Runtime Fabric. You get rolling deployments with zero downtime. You get isolation and the ability to run multiple Mule versions on the same set of resources. And you get high availability with load balancing with Runtime Fabric. And so you can see now, once you compare these three next to each other, Runtime Fabric is really an on-premise deployment, but it brings you those great features and benefits of a cloud deployment. And so we're going to switch gears here just a little bit and start to dig into the Runtime Fabric components and look at the architecture and actually how it works. So when you first look at this diagram, it might look fairly straightforward and you can probably digest it fairly easily by just looking at it. But I'm going to dissect it and we're going to look at the nuances and complexities of Runtime Fabric because it's important to dissect each component. And so let's take a look at controllers first. Controllers are kind of at the top of the screen in the yellow box. Controllers are used to connect MuleSoft's control plane to workers, and it also facilitates traffic from clients to workers. So really the way I like to think about controllers is that it's connecting the external world to your applications. And your applications are known as workers in this scenario. Those are in the blue box at the bottom of the screen. Workers really run your applications. You'll notice that on each worker server, there's isolated applications running on each worker server. And that's facilitated through the use of Docker and Kubernetes. And so what it allows you to do is run those multiple versions of MuleSoft on the same set of resources. It allows each application to fail within the confines of a container and not affect any other applications running on the same set of resources. It also allows you to vertically scale your applications or horizontally scale your applications across these worker servers, which is called replicas with Runtime Fabric. You'll also notice that each controller and each worker server are in different availability zones. And the controllers are also separated from the workers to separate the responsibility and isolate each one from one another. You'll also notice that Runtime Fabric services are running on each server. And so you have to not only plan when you're creating these servers for the size of the application, but you also have to plan for the extra services running on these servers. And that allows you to, deploy and scale and monitor your applications when you have the Runtime Fabric services deployed on each one of these servers. And then you'll notice at the very top of the screen that there's an external load balancer. The external load balancer is used to facilitate the traffic coming from the external world to the controller servers. And then each controller server has an internal load balancer that directs traffic to an available worker server and the application running on that worker server. And the final thing to point out here is this is a recommended production environment where you have 3 controller servers and 3 worker servers for high availability. And if you want more throughput, and depending on your high availability needs, MuleSoft even recommends that you work up to 5 controller servers and 5 worker servers, sometimes even up to 6 of each. And since the last slide got fairly complicated, I want to just look at the data flow coming into Runtime Fabric, because when you look at the data flow, it's really distilled down into 3 steps, which makes it much easier to consume. The first step, client makes a request to your application. And what will happen is that request will run through your external load balancer. That external load balancer will direct that request to an available controller server. And that controller server's internal load balancer will direct that request to an available worker server and the correct application living on that worker server. So once you look at it from that perspective, the flow of traffic actually becomes very simple. And so let's dissect the Runtime Fabric control plane just a little bit. So to explain what the control plane does, the control plane is where you design and create and manage your applications. And the way it works is that MuleSoft's control plane connects with a controller server, and that controller then connects to your workers and allows you to monitor your applications and scale your applications and really keep tabs on all of your applications. So from the management perspective, there's really two pieces. The first one is Ops Center. In Ops Center, you can view your application's logs and monitor your applications. You can even start to get into the bowels and look at the Kubernetes setup that's occurring under the hood. And so Ops Center really is where you monitor your applications with the Runtime Fabric deployment. With Runtime Manager, you might be familiar with this if you're familiar with Cloud Hub. You can scale and deploy and modify and secure your applications, very similar to as if they were deployed on Cloud Hub itself. And so we're going to take a look at installation steps. And by no means is this supposed to be an installation guide. So please don't think of it like that. An installation guide is very well documented on MuleSoft's website. This is meant to be sort of what I did, and then we'll take a look at lessons learned from my installation steps. So a couple things to point out here is that number 4 is actually where you install your Runtime Fabric. And that's right in the middle of all these installation steps. So you notice that steps 1 to 3 is really preparing for your actual installation. So you want to obtain your licenses and create your Runtime Fabric and Runtime Manager and assign appropriate roles and gather all those assets that you need to actually run your installation. And then if you're deploying to the cloud, you can run a Terraform script. So if you're deploying to AWS or Azure, there's just a little bit of configuration you need to do in a Terraform script that's provided by MuleSoft. And then the actual installation, it actually is very slick. So the Terraform script, if you've ever used Terraform, you know that it's used to stand up all of your assets in the cloud. So the Terraform script will stand up everything from VPCs and subnets to your servers and everything having to do with your Runtime Fabric installation. The Terraform script will install for you. It's a very slick installation and a very quick one. And then you verify your installation and you associate that installation with environments in Runtime Manager. And then if you want to, you can enable inbound traffic if that's necessary for your needs. And so what I learned from that installation was number 1, to plan and design before installing. So just like with any project, take a step back, plan and design this project just as if it were any other project. So you have to gather actually quite a few assets and do a bit of preparation before you can actually install your Runtime Fabric. And so I actually failed my install of my Runtime Fabric to AWS the first time because I didn't have the necessary roles set up in AWS the first time. So when I gained the necessary access, I was able to complete the Terraform script, and really the entire install only took about 1 day. So when you have everything ready and all the information and assets ready, you can complete the installation actually fairly quickly. And then I learned that the size of the servers matters. For my installation, for my demo, I run 1 M4 large EC2 instance and 2 R5 large EC2 instances for the workers. And the M4 large instance is for my controller. And this is just a demo environment. So we stood up 3 servers total, 1 controller and 2 workers. So we'd have high availability for the workers, but not for the controllers in this scenario. And you want to plan for the number of servers for high availability. And we'll take a look at a high availability demo here in a minute. But you want to make sure that, for example, if a server goes down, you have the necessary backups and high availability in place that you need for your organization's needs. And so we're going to get into a demo here. We're going to look at many different pieces of Runtime Fabric, including management and security and the logging that occurs with Runtime Fabric. And then we're going to look at how Mule 3 and Mule 4 can both be deployed to the same set of resources on your Runtime Fabric. And then use Alexa to demonstrate high availability with Runtime Fabric. So we're in Runtime Manager here, and within Runtime Manager is where you actually create your Runtime Fabric. And so we have a Runtime Fabric here called RTF Test 1 for our demo environment. And you'll see here that when you create the Runtime Fabric, it's very easy to not only upgrade and manage your Runtime Fabric directly from Runtime Manager here. You can allocate the number of cores and memory to your Runtime Fabric. This is also where you associate your Runtime Fabric with environments that you've set up in Cloud Hub. And then you can enable your inbound traffic here as well, if that's a need for you. And when you enable your inbound traffic, one of the cool things that you can do is implement security policies across all of the applications deployed to your Runtime Fabric. So I've set up a security policy for HTTP limits and web application firewall and denial of service. And I can select all of these very easily and deploy that right away to my Runtime Fabric to have all of those security policies be implemented across my entire Runtime Fabric. And these are deployed at the edge of your network. And so, for example, with Web Application Firewall, it'll start to protect against the OWASP top 10 attacks. And what's going to happen there is you can start to block attacks at the edge of your network and not even allow those attacks to get to your API itself. So really useful security policies there with Runtime Fabric. We're going to look at a couple applications that are actually deployed to the RTF Test 1 Runtime Fabric. So I have two applications for this demo deployed to this Runtime Fabric. And we can see here that the first application we're looking at is a Mule 3 application. We can see that it's deployed to RTF Test 1. If you notice the application URL, it's going to be Pokemon API RTF for our Mule 3 application. We see our Mule 3 application here deployed on version 3.9.3. And you would apply properties just as you would with any other application running in Cloud Hub, for example. This is also where you deploy multiple replicas of the same application. So if you want to scale your application out for high availability, you would deploy 2 or more replicas, and this would deploy your applications to many of your worker servers. You can select a rolling update for your deployment model, so this would give you 0 downtime. And then this is also where you would vertically scale your application. So you can deliver more horsepower to your application here by scaling up the CPU or memory on that particular application. And we're going to see the same thing here for the Mule 4 application. We see that this Mule 4 application is deployed to our same RTF Test 1 Runtime Fabric. This particular path here is going to be Pokemon API RTF Mule 4. And this Mule 4 application is deployed on version 4.2.0. We set the properties in the same way here. I have 2 replicas also deployed of the Mule 4 application for high availability and for the high availability demo. And I also have the ability to scale up the Mule 4 application in the exact same way as I would the Mule 3 application. So keeping in mind the paths that we just saw to the Mule 3 and Mule 4 application running on our Runtime Fabric, we can see here that I'm going to make a request to our Mule 4 application running on our Runtime Fabric here. And what these applications do, just to explain them very quickly, is these all started in a Denver MuleSoft meetup where we started to just use Pokemon as examples. And so both of these applications, what they do is they retrieve Pokemon details. And if you don't know what Pokemon are, they're kind of these creatures that attack each other and have special powers. And we're going to look at what kind of weight and height and special powers each one of these Pokemon actually has. For this particular example, we're creating a request for Pikachu, and we're going to get the details for Pikachu from this Mule 4 application running on our Runtime Fabric. So we see that we've gotten the response for Pikachu from our Mule 4 application. And you can see that Pikachu has electric type moves that are redirected to this Pokemon if it is an eligible target, for example. And it lists some other abilities here for Pikachu. We also know that Pikachu has a weight of 60 and a height of 4. And we have a transaction ID returned here from the API response, so we can track this request across its life cycle. And we'll see that in a minute when we look at the logs for our Runtime Fabric. And we're going to do the exact same thing here for our Mule 3 application. And you can see in this case, we're sending this request to our Mule 3 application. We're going to send the request also for Pikachu. And while I'm doing that, we see that we get a response in the exact same way. If you study the responses from our Mule 3 application here versus our Mule 4 application here, the responses are the exact same format. And so what the use case could be here is that if you're migrating from Mule 3 to Mule 4, not only can you deploy your Mule 3 applications to the same set of resources as your Mule 4 applications using Runtime Fabric, this would be a great use case to actually migrate from Mule 3 to Mule 4. You can start to control the flow of traffic to your Mule 3 versus Mule 4 applications. You can return the same responses, so it would be completely invisible to a client making a request, for example. And so another good use case for Runtime Fabric would be not only to host Mule 3 and Mule 4 on the same set of resources, but to migrate from Mule 3 to Mule 4 if that's important for your organization. So now that we've taken a look at Runtime Manager and the Mule 3 and Mule 4 application running on the same set of resources with Runtime Fabric, we're going to dig into Ops Center here. And with Ops Center, we can start to monitor and view what's actually happening with our applications. So we're going to start in this Kubernetes tab here. And if you notice at the top of Ops Center, we see that our system status is healthy. And we're going to get into a high availability demo here where we're going to bring down one of the servers that runs our application, so one of the worker servers. And you can see here from the Kubernetes tab that we have 3 servers running here. One of these servers is for the controller server and 2 are for the worker servers. And if I take a look at pods, our Kubernetes pods, so this is a Kubernetes term, what we see is that we have 4 different pods. And so we have 2 applications running, one Mule 3 application and one Mule 4 application. And each one of those has 2 replicas associated with it. So Mule 3 application is deployed to the IP address ending in 39 here, and the Mule 3 application is also deployed to, with the second replica, the IP address ending in 26 here. And then we see something very similar for the Mule 4 application, that the Mule 4 application is deployed to the IP address ending in 39. And then we see that the Mule 4 application is also deployed to the IP address ending in 26. So I'm going to use Alexa here to help me out with the high availability demo. And I'm going to ask her a question. So Alexa, open Pandora's box and what's my system status?
The system is healthy.
Okay, so Alexa recognizes that my system is healthy. We see that here. Everything is running. The system status is all healthy here. So I'm going to actually bring down one of the underlying servers with Alexa. Alexa, open Pandora's box and explode my system.
Are you sure you want to wreak havoc on your system? It sounds like you are crazy.
Yes, I do.
Okay, here we go. I will now attack your system. I hope it works out for you.
All right, so while Alexa is bringing down one of the servers in the system, what we're going to see is that Kubernetes is smart enough, if we take a look at deployments here, to recognize that I always want 2 Mule 4 applications deployed and 2 Mule 3 applications deployed in my Runtime Fabric. And very shortly, as one of those servers comes down, we're going to see that I only have 1 available of the Mule 4 application and 1 available of the Mule 3 application, we just saw that flip there, and eventually my system status is going to flip to unhealthy or error. I forgot exactly what the status is. While that's all occurring, we're going to go through Op Center. And I wanted to make a point here of this demo. I've seen a high availability demo with Runtime Fabric before, and that demo gave a demonstration of actually an application running on the Runtime Fabric running out of memory. And so that would be an actual application running on your worker server, kind of going haywire, not affecting any other applications on that particular server. And Kubernetes, again, is smart enough to spin up another node in that scenario. But I wondered for my demo, and the purpose for this demo is that if an underlying server actually crashes, what is the behavior of the system? And we found some really interesting stuff in going through that demonstration. And so that's the whole purpose behind this. And so as that occurs, we now see my system status has issues, but let's go through Op Center here. And so from the admin perspective, what you can do here is that we see, what version of Runtime Fabric we have deployed here. We can download debug info. If we look from the user settings perspective, you can now start to grant users access to Op Center here. So there's two places now. You're going to have to grant users access to Runtime Manager to modify and secure and deploy applications, etc. And if you want users to actually be able to come into Op Center to monitor your applications, these would be additional users here in Op Center. And then we can see that I have 2 servers here now. And when my system status was healthy, I had 3 servers. So we'll loop back to this when the system status becomes healthy again, and I bring up that 3rd server. But right now, as one of my servers is down, we see that I have 1 worker node and 1 controller node. And you can start to actually get access into the underlying servers there. Runtime Fabric is smart enough using the controller node to be able to give you access to those servers. You can also easily add servers here. From the operations tab, what you can see is that it gives you high-level logs of what actually occurred in your Runtime Fabric. So adding a server, installing the cluster, and so on. And then logs become very important. We see that one of my applications here has recently deployed. So as my server went down, this would have deployed another replica of my Mule 3 and Mule 4 application. And so as this is down, I'm going to send more requests to the Mule 3 and Mule 4 application just to prove that I am in fact highly available. So I just sent a request to my Mule 3 application. I'm going to do the same now for my Mule 4 application. And we're going to see that each is still available. So I'm going to pluck out a transaction ID that I got from calling my Mule 3 application. And we can take a look at logs also in this demonstration. So even when one of these underlying servers is completely down, the Mule 3 and Mule 4 application are still working due to the highly available nature of my Runtime Fabric deployment. And so for this transaction ID starting with 238, we should be able to see here that we got details for Pikachu, even when the system status has issues here. So we see that for Pikachu, my Mule 3 application here received an inbound request. It called Pokemon API, and then we got the Pokemon details and returned the response back to the client. So we're fully highly available. The client would not notice any issues here, but we could be alerted in such cases as these to be able to come in and fix the underlying infrastructure in this particular case. Now that we've gone through the highly available demo, let's bring the system back up while I'm taking us through these other tabs. So Alexa, open Pandora's box and what's my system status?
Your system is suffering. You might want to look into that.
Okay, so the system is suffering, and let's make it healthy again. Alexa, open Pandora's box and rebuild my system.
You are lucky that I am all powerful.
Yes, I am.
Okay, I will now restore your system. You are lucky to have me.
Okay, thanks, Alexa. She's so humble. So as she rebuilds the system, let's go through the monitoring tab here. And in the monitoring tab, we can see that we get some really great out-of-the-box monitoring. And you can monitor across a lot of different dimensions. So number one, you can monitor your entire Runtime Fabric cluster. You can monitor the CPU usage on each node. You can monitor memory usage and so on and so forth. There's some really great out-of-the-box monitoring tools that you can use with the monitoring tab here. You can also start to break this down, not only by date, you can break this down by application, ingress, your pods here. There's a number of different ways you can start to break down your monitoring. And then you can also start to monitor each different server that you have running in your Runtime Fabric cluster. And then again, back to Kubernetes. What we see here is that Alexa is bringing my system back up. We see that the unhealthy server is now ready, and what we're going to see is that I now have 4 pods, and this is the interesting behavior of Runtime Fabric, is that when my server went down, what happened is that Kubernetes was smart enough to spin up 2 more replicas of my Mule 3 and more Mule 4 application, and it deployed them to the healthy server. So I brought down the server IP address ending in 2.6, and Kubernetes was smart enough to deploy a replica of each application to the IP address ending in 3.9. And so the interesting behavior here now is that even though I have 2 worker servers ready to go, if I look at my servers tab here and my system status, I'm all healthy. The 2.6 server is completely healthy, but these pods are all deployed to the IP address ending in 3.9. So I'm really glad that I did this demo and took down the underlying server itself, because this behavior is really interesting, where all of these now are deployed to technically a single point of failure. And it goes back to the slide where we talk about the number of worker servers and number of controller servers that MuleSoft recommends. And this is exactly why they recommend at least 3 worker servers for a production environment. So when you have 2 and an underlying server goes down, Kubernetes will deploy all of your replicas to 1 server, and then you're technically not highly available from the infrastructure perspective, and you have a single point of failure from the infrastructure perspective. And to be able to balance these out again onto each server, what you have to do is go back in Runtime Manager, undeploy, stop each application, and then redeploy the application. And Runtime Fabric will do its best to balance out the deployment across your worker servers. So if I were to redeploy this particular Mule 3 and Mule 4 application, after stopping the application, it will deploy the application 1 replica to the IP address ending in 2.6, and it'll deploy 1 to the IP address ending in 3.9, because it's smart enough to balance those out across my worker servers and the availability zones in AWS. But it doesn't do that automatically when you bring down 1 server mid-flight. And so what we see here on the deployments tab again is that I have 2 replicas available of my Mule 3 and Mule 4 application, and my system status is totally healthy again. So finally, that was the demo. We saw Mule 3 and Mule 4 deployed to the same set of resources, and we got help from Alexa to demonstrate high availability. Finally, Alexa, open Pandora's box, and what's the status of my system?
The system is healthy.
Great. So we found that we went from an unhealthy state to now in a healthy state. And I could go back and rebalance the deployments of the Mule 3 and Mule 4 application if I wanted to. That is the extent of the demo. I'm always happy to answer any questions. Feel free to leave any comments or questions in the comments below on the YouTube video here, or you can always reach out to the Denver MuleSoft Meetup group. I organize the Denver MuleSoft Meetup group, and you can reach out to Aaron Lieberman there if you have any questions. I wanted to show this last slide from the PowerPoint here where we have plenty of references and documentation. The PowerPoint is uploaded to my SlideShare account, and you can also find that in the Denver MuleSoft Meetup group from our past Runtime Fabric presentation. And again, you can reach out to me if you ever need any of these slides. So thank you for viewing, and more content to come later.